Students, the last week, I think EZ isomerism I started. EZ isomerism. This geometrical isomerism is trans isomerism only when two groups are same. When two groups are same. With respect to the two groups, we can decide cis isomer or trans isomer. If same groups are same side, then it is cis isomer. Same groups are opposite side, trans isomer. Next one, EZ isomerism. If all the four groups are different, Otherwise, the groups are different. In that case, we can use priority order. Based on the priority order, we will find out E isomer or Z isomer. If same priorities are same side, which isomer, students? E isomer or Z isomer? Same priorities are same side.
Z isomer.
Same priorities are same side, Z isomer. Very good. Same groups are same side, Z isomer. If same groups are opposite side, E isomer. Next, priority order. Priority is directly proportional to atomic weight. C double bond C, COOH, iodine, Cl, OH. Find out, students, whether it is cis isomer or E isomer or Z isomer. See here, out of carbon and iodine, which will get first priority? Iodine will get first priority. Next is second priority. Here, chlorine O. So same priorities are opposite side. E isomer it's. E isomer it's. Next one. And last one. C double bond C, iodine, bromine, C6H5, NHCH3. Tell me, students, which isomer? Z isomer. Dhruva, you are correct. Iodine, first priority. Next one, nitrogen, first priority. Here, carbon, second priority. So, it is no. Carbon and nitrogen, did you take, students? No, it is E isomer. N is connected. And which one you have to here, nitrogen is there. Nitrogen valency is more, no?
Yes, sir. But why do we compare nitrogen and carbon? How do we understand that we should compare those two?
See here, nitrogen is connected here. To the nitrogen, carbon is attached. Now, can you get confusion in that? Nitrogen is directly attached. For the nitrogen, methyl group is attached. No. First priority will be given to the groups which are directly connected to the double bond, isn't it? Chinmay?
Oh, okay. So it should be directly connected to that carbon, that double bonded carbon.
Correct. That we have to consider. Chinmay, understood?
Yes.
Group which are attached to the double bonded carbon directly first priority. If the groups are same, here also same group, here also same group, then you go for second atom. So anyway, here in first case only will come to no nitrogen. Still, if you have any confusion, your nitrogen valency is 3. So this is one bond, hydrogen is forming one bond, methyl group is forming one bond. From this, what we can say, nitrogen is directly connected to the double bonded carbon.
Yes, sir.
Okay, so like this. So this is about EZ isomerism, students. This geometrical isomerism over. Now I'm going to teach optical isomerism. Optical isomerism. So this area students will find difficult, but maximum I'll try to make it very clear. EZ isomerism, if you are if you get confidence, no, you can do this one aramse. Optical isomerism. Slowly only I'll teach students, and clearly I'll try to teach. If you get anywhere confusion or if you find anywhere difficult, please on the spot you ask. Optical isomerism. Optics in physics, you might have got this word optics, not word, chapter only you have, right? Optics. What is optic?
Study of lights.
Study of light. Very nice. Study of light. Here also, optical isomerism means with respect to light, we will distinguish the isomers. Which isomer it is? Optical isomer. So here, before going to optical isomerism, I want to explain some terms. Plane polarized light. These things you should know before entering into optical isomerism. Plane polarized light. What is plane polarized light, students? Anyone knew this? Plane polarized light. Have you heard? Plane polarized light? No, it's okay. First, I'll take ordinary light. See, students, this ordinary light can travel in all the directions. This is about ordinary light. So it is traveling in all the planes, not in one plane. This side, this side, this side, this side. It can travel in all the directions. So vibrations can happen in all the directions. So when this ordinary light, when you pass through the, we call prism. It converts into like this. So now light is moving in one plane only, to and fro. To and fro, we can say up in one plane. So here light is moving in one plane only, and down in single plane. This is called plane polarized light. This is called plane polarized light. What is the function of nickel prism? It converts ordinary light into single plane. So this is called plane polarized light. Light which is moving in one plane is called plane polarized light. What is the necessity of this plane polarized light? I will tell. Plane polarized light understood? Generally, ordinary light travels in all the directions, but plane polarized light vibrating only one plane. So it's plane polarized light. Plane polarized light. What is the necessity of the plane polarized light? Now, side heading optical activity. Optical activity. See, students, the plane polarized light. I'm passing through this. See, students, after passing through this sample, some compounds rotate this light. This is the original direction. From original direction to somewhat right side they may rotate, or some compounds they rotate left side, anti-clockwise direction. This is the original direction. Dotted line is the original direction. Or some compounds they won't change the direction of the light. They won't change the direction of the light. So when we pass ordinary light through the organic sample, wait students, to the given sample, this we can observe from polarimeter. This direction of the light, how it is rotating. Polarimeter. So some can rotate towards the right side or clockwise direction. Some rotate the light anti-clockwise direction or right to left. Some will not change the direction of the plane polarized light. So if they rotate the plane polarized light, if organic compound, listen students, listen, don't write until I finish my explanation. If they rotate plane polarized light, if organic compound, if it rotates plane polarized light either clockwise direction or anti-clockwise direction, that compound is said to be optically active. Optically active means it is doing some work on the light. So it is active. Some compounds, they don't change the direction of the light. Those are called optically inactive. Optically active. And this process is called optical activity, or this phenomena is called optical activity. Right now? Compounds. Understood students? What is plane polarized? Suppose, why did we take this one? Why we took plane polarized light? If we take ordinary light, we can't observe the movement, observe the change in which direction, because all the directions it moving. No, we can't find out which direction this light is moving or what is the activity of this organic compound. We can't find out. For that reason, we are using plane polarized light. If it is moving in single plane, we can easily make out which direction it is rotating. If it is moving in all the directions, we can't find out, can't make out any movement. Okay. This is the reason we converted ordinary light into plane polarized light. Okay. If it rotates either clockwise or anti-clockwise direction, these compounds are called optical active compounds, and the phenomena is called optical activity. Right? Optical activity wrote no side heading. So compounds which rotate plane polarized light. Compounds rotate plane polarized light either clockwise direction or anti-clockwise direction. The clockwise direction or anti-clockwise direction are called optically active substances. And the phenomena is called optical activity. Phenomena is called optical activity. Compounds which do not rotate plane polarized light or which do not alter the plane polarized light, also can write, are called optically inactive substances. Optically inactive substances. Side heading: optical isomerism students. Optical isomerism. Compounds having similar physical and chemical properties. Compounds are having same physical and chemical properties. But differ only in the behavior towards polarized light. Are called optical isomers. Yes, they refract. Optical isomers. And the phenomena is called optical isomers. Isomers. Next side heading. Conditions for optical isomerism. No, they transmit the light. They transmit the light. Seven.
Are they transparent or optically inactive substances?
No, both are having same property, but towards the light, that light will move. Light will, they allow the light inside. I mean, what we call transmission property, right? After entering into the sample only, it will happen. Some compounds they rotate. Some it's like I will show one general example by taking one general example. Same condition I am going to utilize to explain optical activity condition. In this, in which case symmetrical arrangement is there, students? Out of first is 1 and 2, which case symmetrical arrangement is there?
The first one.
Other students? Anaga correct answer, Jyoti correct answer. First one, all the spheres almost same, exactly I couldn't draw, symmetrical. In second case, one is large sphere, another one is small sphere. So here, when the light is passed through this, it reflects like this. It changes the direction like this. Next, after coming this, again it will become proper. Now, suppose if light enters in this direction, it will, sorry. So after this one, it will change the direction of the light. Again, it will change. It will change very badly afterwards. Light may go in different direction, not like how it entered in the same way it has come out. But here, it's changed, slight direction, it has changed, direction, it will change. Why? Here, how much it changes here, so much here also it will try to correct it. Then it will change here afterwards. See, like one best example is this is one paper, one students. Light entered like this. One molecule made this like this. Like this. Next, one more molecule. Because of the straight line, it entered as a straight line, right? Light, you just imagine. Because of one molecule came like this, diverted. After entering, one more molecule came like this. Like this. It's not an exact example, just to imagine how what process will happen inside. So if it goes to next molecule, again reverse process takes place. It becomes straight. Again, after entering one more molecule, it becomes like this. Like this. See, while entering it, enter like this only. After coming out of the sample, also has come out in the same manner. So here, rotation compound has not rotated this one. Rotation didn't occur. This compound is optically inactive because same spheres, same size spheres. If you take symmetrical arrangement, if you take, it is entering like this. Afterwards, because of one sphere, direction of the light change like this. Because of another sphere, direction of the light change like this. Not only two molecules, here different molecules will be there, 4 molecules, each carbon connecting with 4 other groups. If they are same, what will happen? If they are different, what will happen? I am going to explain. If they are same, so equal magnitude it will get, equal effect it will get from all the spheres. First two spheres made like this. Next two spheres, that this became, so here this will become, what is this? One somewhat direction changed. So, third sphere will make like this, fourth sphere will make like this. If all the spheres are symmetrical, there won't be rotation. You can't see any rotation here, any rotation. If all the four spheres are different, you can see the deflection of the light, deflection of the light because of unsymmetrical effect, unsymmetrical effect. So he asks, Shravan Bhatt is asking whether optically inactive substances are opaque. No, both are allowing the light. What we say, transmitting the light, transmitting the light. But in case of symmetrical arrangement, that I am going to explain with respect to groups. Conditions of optical isomerism. Shravan Bhatt.
Yes, sir.
See here, in both the cases, they allow the light. But in case if carbon is connecting with same groups, at least any two same groups, if it is connecting with at least two same groups, there won't be any rotation. If all the groups around the carbon are different, then rotation of the light is possible. Rotation of the light is possible. Now in this, I am going to explain conditions for optical activity. Conditions for optical activity. The paper I explained. Now if I take groups, you will get more clarity. Conditions for optical activity. First condition, compound must contain at least, right now, star marks you put and write. Compound must contain at least one chiral carbon. Chiral carbon, and compound shouldn't contain plane of symmetry. Shouldn't have plane of symmetry. These are the two main conditions. I will explain one by one. What is chiral carbon? What is plane of symmetry? There are two conditions mainly to exhibit optical isomerism. One is compound must contain at least one chiral center. Second one is compound shouldn't have plane of symmetry. See students, chiral carbon, just now I told, carbon if it is surrounded by four different groups, then that carbon is called chiral carbon. Right, Anna? Chiral carbon. Carbon must contain four different groups. This chiral carbon is also called asymmetric carbon. Chiral carbon, chiral center, stereogenic center also we call. sp3 hybridized carbon. Do you know sp3 hybridization, students? sp3 hybridization. If you
No,
don't
sir.
know, sp3 hybridization, I will tell you one simple point that you remember. sp3 hybridized carbon means carbon must connecting with 4 single bonds only. No double bond should connect. No double bond or triple bond. So here I will use sp3 hybridized. sp3 hybridized means carbon is connecting with all 4 single bonds. sp3 hybridized carbon connecting with the 4 different groups. Four different groups. Example, you only tell me, students, chiral carbon, which is chiral carbon, which is not chiral carbon. Once if I give these examples, you will get clarity. I will revise once again. After explaining the examples, once if I write all the optical isomers, will explain once. You will get more clarity that time. Now listen all those things, basics you listen. This is one carbon connecting with the OH here, CH3, CH2OH, hydrogen. Does this carbon chiral carbon or not? Yes, it is a chiral carbon because OH is one group, methyl is one group, CH2OH is another group, hydrogen. All 4 are different, so it is a chiral carbon. Generally, for chiral carbon atoms, we will put star mark. Next, I will write one compound. In this compound, how many chiral centers are there? How many chiral carbon atoms are there? So, like this, if they ask, do one thing, students. First, one example I will explain. Rest you can do. CH3, I am writing like this. Anyway, 3 hydrogens are there. No, same groups are there.
2, sir.
Yes, correct answer. Very nice, Dhruva. Oh, sorry. Hydrogen. See, students, anyway here, 3 hydrogens are same. It is not a chiral carbon. But this carbon, if you see, one is OH, one is methyl group, another one is hydrogen, another one, this entire thing is one group for this, with respect to this carbon. So, how many chiral carbon atoms are there? This is one. This is one. Understood, students, how to find out number of chiral centers?
Yes, sir.
And sp3 hybridized condition I said no. See, students, all the bonds are single bonds only. No double bond, no triple bond. So that carbon is called sp3 hybridized carbon. Now I can't explain hybridization. No time. So for time being, you remember like this. All must be single bonds. Next, shall I give one more compound?
Yes, sir.
COOH, CHOH, CHOH, COOH. How many chiral carbon atoms are there? See, students, here COOH. COOH generally how we will write like this, isn't it? COOH. Here carbon is connecting with double bond O, and this oxygen also is there. No, it is not chiral carbon. Here, if you see second carbon, one is carboxylic acid, one is hydroxyl group, another one is hydrogen. And this entire thing is one group, students. This entire thing is one group. Like that only consider every time. Okay. So now, how many carbon chiral carbon atoms we got? This is one. This is one. Hope you understood how to find out chiral carbon atoms. And one simple example I'll give. Do it. CHO. Middle, this is the carbon. HOH. How many chiral carbon atoms are there? Yes, if it is having double bond, it cannot be. Start and copy it. How many are there? Tell me, students. I told you, no, one hint I will give. While considering this carbon, CHO is one group, H is one group, OH is one group. This entire thing is one group. This entire thing is one group. Like this for everything, do it. And find out how many chiral carbon atoms are there. See, students, this is chiral carbon atom only because all four are different. Next, this one also. With respect to this one, this entire thing is one group. H is one group, OH group. This entire thing is one group. Same thing here also. So total 4 you will get if you want check properly. Four you will get. Here this carbon anyway you can't consider because 2 hydrogens are there. Here double bond O is there, so you can't consider. CHO means C double bond O H, right? Next side heading. Here there are some terms. And one more point I said, no, chiral carbon. How to identify chiral carbon atom? I explained. Next one, how to find out plane of symmetry, whether plane of symmetry exists or not. How to find out? Stop writing, students, all of you. H, OH, OH, COOH, COOH. COOH. Now, if you draw one plane like this, it is dividing the molecule into 2 halves, isn't it? This one part is mirror image to another one. Understood? See here, H. If you consider it as a mirror, H, H, OH, OH. Group which is far from the mirror, here also it is far from the mirror. Okay. In some books they are giving like equal halves. Equal halves means H can be here, OH can be here, OH can be here, H can be here. That will not define properly. It should be mirror image. Should be mirror image to each other. If you see your face in mirror, face only should come, not legs, not hands. If it covers, it will come, but instead of face, back side of your head, if it comes, it is not mirror image, isn't it? Understood, students, what is plane of symmetry? If you draw one plane, that plane must divide the molecule into two equal halves. It's like those parts both should be mirror image to each other. Mirror image to each other. Shall I give one molecule? You just identify whether plane of symmetry exists or not. You only tell me. Plane of symmetry is present or not? If it is present, yes, you put. Otherwise, no, you send. No plane of symmetry. If I divide, do you think is it mirror image for this? Here H is there, OH is there. Is it mirror image? It is dividing the molecule into equal halves because once HOH, CHO, OH, CHO. Groups are, number of groups are same, but it is not mirror image, isn't it? That's why I told first condition you don't follow. Should divide equally means or both sides equal groups are there now. So it is dividing equally. That you don't consider. After division, one must be mirror image to another. They must be, the divided parts must be, this plane is there now, that must be like a mirror. Then only Chinmay, plane of symmetry exists or not? Tell me here.
No, sir.
It's not possible. Samarth got it.
Yes, sir.
So if the molecule is having plane of symmetry, then in that case also optically it is not active. So optically inactive. Understood? This is about plane of symmetry. One more here I will take to avoid the confusion. No plane of symmetry. So these two examples, if I give you, you won't get any confusion. Their groups are equal, both sides, but they are not mirror images. It should be mirror. H should be mirror image. Here H should come here. OH means here down also OH should come. Then only plane of symmetry will consider. Otherwise, will not consider plane of symmetry. Students, any doubt regarding plane of symmetry? If you have any doubts, tell me yes. Otherwise, go to the next.
Sir, I have a doubt about benzene ring.
Benzene ring.
Yeah, in the textbook, it's given like a hexagon and a circle inside it. Why is that so? You said that it has 3 double bonds, right?
Yeah.
Then why is there a circle inside that hexagon in textbooks?
Okay, I will. No, I am asking here any doubt? Tell me, students, if you tell, I can
No.
finish it fast.
No, sir.
He is asking, sir, why is that ring inside? Actually, can write like this? No. In some books, it will be like this. Shravan.
I think people are lazy to draw all those lines alternative way.
No. This is correct. This one is also correct. I am giving the numbers 1, 2, 3, 4, 5.
No, sir. In some textbooks, there will be a circle inside the hexagon.
Wait. For that only I am giving explanation. Next, here also I am giving the number 1, 2, 3, 4, 5, 6. See here, double bonds are present in between 1 and 2 carbons, 3 and 4 carbon atoms, 5 and 6 carbon atoms. The same place I started number here in between 2, 3 carbons, 4, 5 carbons. Next, 1 and 6 carbon atoms. Both are same only, I will tell you. Both are same. In this, so this is the conform or this is perfect one, this is not perfect one, we can't say. This we can do only the molecule where the resonance occurs. Where the resonance means these double bonds are not static here. They rotate from here to here, they delocalize from here to here. The entire ring they rotate. These 3 double bonds are there, no? These double bonds rotate, revolve an entire ring. Means they cover all the 6 carbon atoms in this way.
Three-dimensional, right?
Yes, they can be in between 1 and 2 carbons. Double bond can be in between 2, 3 carbon atoms. Here now it is here. Afterwards it will be here. Okay, this is called delocalization of pi electrons, or simply we call resonance. Delocalization. So this benzene can be like this, like this. So this hybrid structure, how we'll write? So these double bonds are not permanent in between any 2 carbon atoms. To represent this, we are using hybrid. This is called resonance hybrid. So actually, we have to write benzene like this. Inside the circle should be like this. But nowadays, people are writing this much big ring. They'll draw small. Actually, it is. If I correct the paper, I'll put 0 marks. This is not correct representation. This pi electron cloud is there. No, it should be close to the ring. Shravan got it?
Yes, sir.
So pi bonds are not static in between any 2 carbon atoms. This will revolve around the ring. For that reason, we are showing the circle. So optical activity conditions you got to know, students. Chiral carbon atom should be there. At least one chiral center should be there. Chiral center means all the 4 groups should be different around the carbon. Next one, no plane of symmetry. Plane of symmetry, how to find out? When we draw the plane, this plane should be mirror for the 2 groups, 2 parts. Then only you can say the plane of symmetry exists. Otherwise, no plane of symmetry. No plane of symmetry means optically active. Okay. Now, here I am going to introduce few more words. Enantiomers. Enantiomer. I am drawing like this, means there is one carbon here. There is one carbon. That cross is there, and there one carbon is there. This represents like here OH is, sorry. Here CHO is there, OH is there, H is there, CH2OH. This is mirror, students. Mirror I am keeping. OH, here it will be hydrogen. Okay, it is a mirror image for If I lift this P and if I keep upon first one, are they coincide, students?
No, sir.
No. This is called non-superimposable mirror image. These are called non-superimposable mirror images. Hope you understood what is superimposable, what is non-superimposable.
Yes.
So, if they form non-superimposable mirror image, those are called enantiomers. Those are called enantiomers. Compounds or mirror image to each other and are not non-superimposable. Those are called enantiomers. So this one and this one, can we say now enantiomers?
Yes, sir.
Yes.
Only Jyoti is telling Chinmay, others they are not giving any reply. Enantiomers or not?
Yes, sir.
Enantiomers, because they are mirror image but not superimposable. Compounds which are mirror image to each other, or simply you can write in one sentence only, right, students? Compounds which can form non-superimposable mirror images. Compounds which can form non-superimposable mirror images are called enantiomers. Enantiomers. Non-superimposable mirror images are called enantiomers. Done, students? I will give one more molecule. Are the enantiomers, students?
Yes, sir.
Very good. Enantiomers. Understood how to find out enantiomers? Mirror image, and they are not superimposed. If you lift this molecule and if you keep upon this, OH will come on H. This OH will come on H. This will go here. Next side heading, diastereomers. Diastereomers. Tell me, students, are they mirror images?
No.
Are they mirror images, students? In the beginning, at least 10 members, they are not mirror images. So, if they do not form mirror image, those are called diastereomers. Those are called diastereomers. Now, these two are. If they are not mirror image, no need to check superimposability and all. What are diastereomers, students? Compounds which are not mirror image to each other are called diastereomers. Diastereomers. These are all types of optical active compounds. Types of optical active compounds. Enantiomer, diastereomers are types of optically active. Number of stereomers while writing, we may get enantiomers, we may get diastereomers, we may get meso compounds. So I am giving meso compounds. I will give example, students. You only tell me what you observed in this meso compound. Earlier also I had given this example. What did you observe, students, in this?
It is symmetric.
Which symmetry?
The horizontal line through axis will be the horizontal.
That is only plane of symmetry, you tell.
Yeah.
I got it, Chinmay.
Yes, sir.
Naga.
Yes, sir.
Okay. Here, plane of symmetry exists. Compounds in which plane of symmetry exists, they are
These are optically inactive, right?
optically inactive. These are called meso compounds. I will tell why it is optically inactive also. Advait correct. Plane of symmetry is. Understood, student? Meso compounds means these compounds plane of symmetry exist. Axis of symmetry exists. Plane of symmetry or axis of symmetry exists. Understood? Now, enantiomer, what I said, mirror image, but non-superimposable. Diastereomers, they won't form mirror image only. Meso compound, there is a plane of symmetry. These are the main three types of optical stereoisomers. One particular compound, we can write it in these three ways. If one compound is getting 5 isomers, means in that 2 enantiomers, 2 diastereomers, 1 meso compound, like that division will be there. These are the types of stereoisomers. So compounds in which plane of symmetry exists. Okay, enantiomers, diastereomers, meso compounds. For this, how to give the configuration? First one, relative configuration they introduced. Relative configuration. Why we are using relative configuration? In the year 1951, they introduced relative configuration because that time much technology was not there to find out absolute configuration. So relative configuration, by taking one standard compound, they explain the configuration of other substances. That what is the standard reference? Here, the standard reference is glyceraldehyde. This is the formula of glyceraldehyde. See, students, if this OH is right side, D-glyceraldehyde, OH is its mirror image. If you take, then OH will be left side. This is L-glyceraldehyde. T-glyceraldehyde. D-glyceraldehyde, main heading I forgot to. Absolute configuration. Sorry, relative configuration. It's very simple, nothing is there. DL isomerism. You can write DL isomerism. DL isomerism. So these are the references. By using this, how to find out configuration of other substance? I will take very big molecule. CH3. See here, students, last one, if you see, last OH. Sir, one OH is right side, one OH is left side. That you don't consider. Last but one you consider. Here, OH is left side, so L configuration. L configuration. Its mirror image if you take D configuration. I'll take one more. One, two, three, four, five, six. See students, here in this group CH2OH. Here OH is present. It is similar to the first one. So D-glucose will say this one. D-glucose. For this L-glucose, if you want, no need to change entire thing. Only last group if you change enough. L-glucose. Understood, students? DLL configuration, how to decide? Many OHs are there. Last but one you take if it is present right side. D configuration if it is present left side. L configuration. Very simple relative configuration. Now I will give two examples. You only tell me whether it is L form or D form. L form or D form, students?
L form.
Very good. L form it is. Minus form also you can keep. Next, for this, one more I will write. OH, H, H, OH. OH, H. No. I want to write something I wrote. Look at side students. HOH. Tell me.
D form.
D form. D for dextro-rotatory, L for levo-rotatory. D for dextro means right side. L for levo. Left hand direction. Left hand. Can you identify, students? Next one, absolute configuration. Absolute configuration is octal. Here absolute configuration R isomer and S isomer. Rectus, sinister, R and S isomers. RS configuration also is very simple, students. EZ isomerism, how we took priority order, same thing here also. RS configuration. Priorities we will take. Priorities. There for double bonded carbon atoms, here single bonded sp3 hybridized carbon. See, students, first suppose here fourth priority is here, first priority, second priority. Priority, if you draw like this, is it clockwise direction or anti-clockwise direction, students?
Clockwise.
Clockwise direction. If it is clockwise direction, fourth priority must be on vertical line. If fourth priority on vertical line, clockwise gives R configuration, anti-clockwise gives. So while applying for the compounds, you will get more clarity. S configuration. So now this is R configuration. Fourth priority is on horizontal line. Priority is moving left to right, means clockwise direction. Next, if the priorities are like this, fourth priority, 1, 2, 3. So now priority is moving like this, anti-clockwise direction. S configuration. You may get doubt, sir. 1 is here, 2 is here. In this case, which direction we have to follow? Through 4 we have to follow, or 3 we have to follow. Every time we have to follow 4. Clockwise direction. This case, if you remember, nothing is priority. How you know? Priority, however, you know, in E and Z configuration, we got to know. Priority is directly proportional to atomic weight. Atomic weight. I'll give some few examples. We'll try it. Understood, students? First, copy these things. Corning gold prelogs rules. Priorities will be given. Again, I am not teaching these priority rules and all, students. Priority is directly proportional to atomic mass. Atomic masses. So same rules in EZ isomerism. Whatever the rules I taught, same rules applicable here also. Now I will give one compound. I will explain, not giving. Just whatever the rules now I gave, that you apply. Here OH, H, CH2, OH, CHO. Out of these 4, which will get first priority, students? Which will get first priority?
H.
Here OH is there, means total mass you no need to add. O is connecting directly. Here H is connecting directly. Here carbon is connecting directly. Here carbon is connecting directly. Out of O, H, C, which is having higher atomic mass? O is having higher atomic mass. Which is having higher atomic mass?
Oxygen.
Oxygen has high priority. First priority. Next. Oh, here carbon is there, here carbon is there. How to decide, students?
Next closest.
Huh? Which will get first priority? CHO 1, CH2OH is there. I told you note C double bond O is there means 2 oxygens you have to write. Double bond O means 2 oxygen CHO. CH2OH COHH. Which will get first priority, students? C will get cancelled. O. Next one also here O, here hydrogen. So this will get second priority. Heated isomerism, if you practice, it will be easy. So now priorities are moving like this. Clockwise or anti-clockwise, students?
Anti-clockwise.
Anti-clockwise. So which configuration it is?
S configuration.
Yes, configuration. Understood this one? First priority orders you give. Don't count entire molecular mass, which atom is directly connected to the chiral carbon. This is the chiral carbon atom. For that, we gave the configuration. Understood? Yes, configuration we got. Shall I give one more?
Yes, sir.
Yes, sir.
For this, you tell me, students, which configuration? Very, very important, students. Here, OH. O is first, right? O will get first priority. Next, here carbon, here carbon. Here CHO, right? COOH. Here C, higher atomic mass, you keep next HH. So this will get second priority. Third priority, fourth priority. So this is R configuration. Since clockwise direction, fourth priority is on horizontal. Clockwise means like this, left to right. Anti-clockwise means right to left, like that you remember at least. Shall I give one more compound, students?
Yes.
Next. Br, chlorine, hydrogen, COOH. Tell me the configuration. R configuration. See here, priority orders. Bromine, highest atomic mass. Next, chlorine. Anyway, this one is least. Third. Clockwise or anti-clockwise, students?
Clockwise.
Clockwise. So R configuration. Only so much. Nothing is there. Next, COOH, NH2, H, CH3. COOH means like this it is, student. COOH. CHO means like this it is. Cn means like this it is. In all these things I explained in EZ configuration. Once you revise, if you get the grip, you can do it better. Dhruva,
Yes, sir.
which configuration?
I think S configuration.
Why are you thinking S?
Because it goes anti-clockwise.
I'll check. Even I didn't do. One, here carbon, but next one is oxygen. Two. How it is anti-clockwise?
Oh, I did the other way. Like I started from COH. I thought hydrogen is connected to that.
Yeah, actually,
Nitrogen.
here one separate rule I have to give students. Those who put S configuration, I don't know by luck you put or what. Yes, only correct.
By luck.
See here separate rule I am going to give. If see here least priority means if fourth priority is on horizontal line. Horizontal line. Then above configuration will be ulta students. Horizontal line. Clockwise gives S configuration. This is the last rule. Means it will be reversed. One if you remember, next one will be anti-clockwise or configuration. These two things if you remember, over. Priority anyway, by knowing atomic masses you can give. Fourth priority if it is on horizontal line, vertical line, clockwise gives or anti-clockwise gives S. If fourth priority is on horizontal line, clockwise gives S, anti-clockwise gives R configuration. Okay. So now this one is clockwise, but fourth priority is on horizontal line. One or two compounds, you write this one. So S configuration it is. Put star marks and write. These two things, if you know, RS configuration, fail katam. Iodine, H, Br, Cl. Tell me students. You need practice only so much. But whatever I am giving rough work, everything you copy it. It's going to be easy. Fourth priority check students where it is. Okay. This is the first one, second one, third one, fourth one. Yeah. Somewhere I only went from. Iodine first priority, bromine second priority, chlorine third priority. Clockwise, fourth priority is on horizontal line. S is correct, students. Those who send yes, they are correct. Now, last compound, with only one center, chiral center. CH3 H CHO C2H5. C2H5 you can also write like this. Tell me the configuration. CHO, you have to write like this. COOH. Here, CH2, CH3 I said no. First carbon will come. Next also carbon will keep. Carbon is connecting with carbon. Next all are hydrogens only. Here carbon, hydrogen, 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 3 hydrogen. Here I wrote already. COOH. Like this, if you write, it will be very easy, students. Here C, here C, here C, all cases. But next one is here O. Next one here hydrogen, here. So which will get first priority? CHO will get first priority. Next CC, CH. So this will get next priority. Third priority, fourth priority. Clockwise direction, fourth priority is on vertical line or configuration. Oh, Anaga, sorry, I thought this compound configuration or configuration. Understood, students, how to analyze? Write separately until you get the proper perfection. Now I am going to do with 2 chiral centers. 1 or 2 examples I will take with 2 chiral centers. H, COOH, CH2OH. So this is one chiral center. This is one chiral center. See, students, here also carbon is connected with the carbon directly. Correct, carbon O. So this will get first priority. Next, out of this and this, which will get first priority. If you want this, you write like this: carbon, C double bond O, right? O, O, one more O is there, H. Next, this carbon connecting with this is C, OH, H, next CH2OH. These are the groups attached to this carbon. Okay. Now, carbon is connecting with the carbon. Here also carbon only. So this will get cancelled. Here O is there. Here also O is this connecting to O. But rest are hydrogen here, carbon here. But here oxygen only. This O is connecting through this, not directly. But here O is connecting to this carbon directly. So this will get second priority. This will get second priority. This will get fourth priority. This will get third priority. So for this carbon, anti-clockwise direction, but fourth priority is on horizontal line, right? So R configuration. For this, if you see, I'll change the color, students. This one will get first priority. Here carbon, here also carbon. Next group is here O, here O. Next group is here hydrogen, here carbon. So this will get second priority, third priority, fourth priority. So this one also like anti-clockwise. This one also R configuration. both are getting R configurations. Writing groups as it is, students. Should I explain it second? Okay, I will explain once again. This molecule, I will take it in another slide. DPP, I will try to send students. If you find this two centers difficult, ignore it because a little higher level. Now, what I am doing, this is one carbon, isn't it? Chiral carbon. This is one carbon. So I will write it separately. But this carbon is connecting with the COOH. You just make it parts. And this carbon connecting with the OH, H, CH2OH, isn't it? CH2OH. This is this group downward. So if you consider, sorry, this one priority order, how to keep this carbon is connecting with O. Carbon is connecting with the O. Next, this carbon. Afterwards, this hydrogen is directly connected. These are the groups directly connected to this carbon. Yes or no?
Yes, sir.
See, here OH is connecting directly to this. So out of O and carbon, hydrogen, which is having higher atomic mass? O. So that I kept first. Next, this carbon is directly connected with C. So I wrote next. This carbon is directly connected with hydrogen. Why did you write O first, sir? O atomic mass is more. So while fighting with other country, we'll use strong weapons only. So while it's having damaged weapons and strong weapons, we will use strong weapons only. Otherwise, they will kill us. No. Okay. Same thing. Higher atomic mass only will keep first. I have O here. I have hydrogen here. I have carbon here. Which will keep first? O, C, H. This clarity, if you have, you can answer not only 2 chiral centers, 10 chiral center compound. If they give also, you can do it. Okay. Now, shall I start now? So now first priority, anyway, O is directly attached to this. O is directly attached to this. So first priority will be given to this. Next, here I told you, C double bond O means 2 oxygens and 1 OH is there, that will write. H anyway least priority. There is a competition between this carbon and this carbon. Okay. Now C, how much strong weapon we use? Same thing they used. Here get one set. But here O is there, here carbon is there. Which will get first priority, students?
O.
O will get first priority. So now COOH will get first priority. This will get third priority. Only so much I did. 2, 3, 4. Understood, students?
Yes, sir.
So it is clockwise direction or anti-clockwise, students?
Anti-clock.
Anti-clockwise. Fourth priority is on horizontal line or configuration, right?
Yes, sir.
Understood now? This carbon, if you understand, next one is very easy.
Yes, sir.
Next, here also same thing. O comes first. O comes first. Here carbon is there, here carbon is there. Here O is there, here also O is there. But here all are hydrogens, next one is carbon. So first priority is here, second priority will come here, third priority is here, fourth priority is here. This one also same, R configuration. Two are having same configuration, R. Check once. Okay, so if you give numbering 1, 2, 3, second carbon is getting 2 R configuration, third carbon also getting R configuration. If you want, right? Huh?
Is it possible only with chiral carbons?
Yeah, with chiral carbon atoms, compounds only can rotate the plane polarized light, right?
Yes, sir.
Chiral carbon atoms. This is about optical isomerism. Understood, students, how to do?
Yes, sir.
Students understood. Shall I go to reaction with this optical isomerism over?
Yes, sir.
Shall I give one more with the 2 chiral centers?
Yes, sir.
One you do it. We'll go to other topic because the time is less. At a time, if you do not understand, just practice like this after the class, whenever you are free. Both are not same compound, students. One is COOH, this one is CHO. Try, students, this one. See, students, where you went wrong, you check once. O, C, H, C. Which will get first priority? O will get first priority. Next, here CHO means COOH. Here, what are the groups around carbon? C, O is there, no? O I will write first. Again, C is there, no? C I will write. Next, hydrogen. This much is enough to decide. So here carbon will get cancelled, O will get cancelled, O and C, which will get first priority, O will get. Where is there? Where it is 2. Fourth priority, third priority. Why are you thinking so much, students? I didn't understand. This JR batch people, aram se did it.
Sir, it is horizontal, no, sir. So it should be yes, right?
Yes, conflict. It is a clockwise, sir, anti-clockwise.
No, sir, it's horizontal.
It's horizontal only. No, I'm asking. It is anti-clockwise, no?
Yeah, it's anti-clockwise.
Anti-clockwise, then R configuration, right?
Yes.
R configuration.
Yes, sir.
Next, O is there. Same thing. Here carbon is there, here carbon is there. Here O is there, here O is there. But here rest all are hydrogens only. But here carbon is there. So second priority will go to this one. Fourth priority, third priority. This is the first priority. Same. 2 or 3 or 1, 2, 3 numbers. Nothing is there, students. Same compounds you practice after the class. EZ configuration, all those things. After preparing EZ configuration, you go to this. Only two rules I said. One is fourth priority is on vertical line, clockwise gives R, anti-clockwise gives S. Fourth priority is on horizontal line, clockwise is S, anti-clockwise is R. Those things you keep in mind. In textbooks and all, they are giving horribly. If they are changing the rotations, shiftings and all they are doing, don't worry, don't want those things. You follow these methods. So next topic, reaction mechanism, students. Last topic in this foundation, in this course, this year's course, reaction mechanism. Reaction mechanism. All of you stop writing, students. In A2, bond will be like this. AB molecule, if I take, bond will be like this. Here, bond formed by two electrons, right? Equal contribution of electrons. If both are identical atoms, this bond pair of electrons will be at the center. If both are not same, that one will be more electronegative and there will be less electronegative. So electrons will move towards more electronegative atom. Yes or no? So that time one will get partially negative charge, another will get partially positive charge. Here no charges. This property is called polarity. Polarity means getting poles, positive pole, negative pole. Here it is unequal distribution of electrons. Polarity, this is because unequal distribution of electrons. Unequal distribution of electrons. You know, bond means two electrons will be there. These two electrons, if they distribute equally, no polarity. No atom will lose, no atom will gain. But in that one is more electronegative. It is attracting towards itself, two electrons. Then one will be getting positive charge, partially positive charge, another will get partially negative charge. Partially negative charge. Yeah, generally carbons contain covalent bond, right, students? Covalent bond. Covalent bond means equal number, equally contribute the electrons and share between the two atoms equally. Okay. Understood, students? What is polarity? Suppose myself and Samar started business. I want to start 10 lakhs business. He want to start 10 lakhs business. But he has only 5 lakhs. I have 5 lakhs. We can't start individually. So what we did, we contributed 5 lakhs. We started business and profit, whatever we are getting, sharing equally. This is only covalent bond. But one day, I got one illegal thought. What, you know, like this profit, if I get monthly only 10,000, 20,000 only I'm getting. Instead of that, if I take everything, one night everything, if I shift everything in this business, I will get this 5 lakhs also. Or I am taking more profit by doing some illegal things. So that time, Samarth is losing something, I am getting extra things. He is losing partially, I am It's not completely take over. Just I'm taking more profit without telling properly. Means sincerely I am not distributing. That time somewhat he lose, some I will gain. That is polarity. One is gaining more, one is losing, one is gaining less. So this is same thing here also. Unequal distribution of electrons leads to the polarity. The polarity thus produced in the molecule as a result of higher electronegative element is called inductive effect. Now we put side heading inductive effect. Inductive effect. What is inductive effect, students? This is the carbon chain. Chlorine is there. Chlorine is more electronegative than carbon. So carbon will get positive charge, partial positive charge. Chlorine will get partial negative because electron movement is towards the chlorine. So these are the losers. This is the atom gaining electrons. This effect is called inductive effect. This effect is called inductive effect. Permanent displacement of, right now definition. Permanent displacement of sigma electrons, not pi electrons, towards negative atom, towards more electronegative atom is called inductive effect. Understood? One atom is more electronegative, another atom is less electronegative. So more electronegative atom try to take electrons towards itself. This is called inductive effect. Now, this inductive effect is classified into two types. Easy only, student, nothing is there. Inductive effect is classified into two types. Plus psi effect, minus psi effect. Only basics I'll use, students. Don't take any tension. Basics I'll give upon this. If you find it difficult, I'll give only basics and I will leave you. Plus psi effect, minus psi effect, because optical isomerism and all you learned in little standard way. So this I'll give basics. Plus psi effect means for your range it is more. Foundation range it is more. Whatever we learned. Plus psi effect means here C carbon chain, students. If the group attached to this X I will take is giving electrons. If the attached group it gives electron, carbon will get negative charge and that group will get positive charge. This effect is called positive effect. With respect to the attached group only we'll discuss. So here group is giving electrons to the chain. This is called plus psi effect. Here observe this one. Both if you observe you will come to. Here Y is one group. It is taking electrons. That time this will get negative charge. This will get positive charge. So here if here this one is getting positive charge, plus psi effect. Here this group is getting negative charge, minus psi effect. What are the plus psi effect groups? What are the minus psi effect groups? Which are releasing electrons, which are taking electrons. All alkyl groups are plus psi effect groups. Example, methyl group, ethyl group, isopropyl group. All these things are plus psi effect groups. Example for plus psi effect groups. Minus psi effect groups, electronegative atoms like NO2, fluorine, chlorine, all halogens, CN, all carbonyl compounds like aldehydes, ketones, carboxylic acids. These are all minus psi effect groups. Minus psi effect groups. Okay. These groups, for time being, these groups, all halogens, all carbonyl compounds, nitro compounds, CN compounds are electron withdrawing group. Mean these are taking electrons. One or two applications I will give students upon this. Afterwards, I will leave you. So first, what I said, inductive effect means displacement of electrons towards more electronegative atom is called inductive effect. This inductive effect classified into two types: plus psi effect and minus psi effect. Plus psi effect means if the group attached to the carbon chain, if it takes plus psi effect, if it gives electrons to the carbon chain, plus psi group. If the group is taking electrons from carbon, minus psi group. Example for plus psi and minus psi groups I gave.
So can you repeat the examples for minus psi group?
Nitro group means more electronegative atoms are there, no? Fluorine, chlorine. They take electrons. These are all more electronegative than carbon. So they take electrons. So those are called minus psi effect groups. They take electrons from carbon. They are all more electronegative than carbon. So they take electrons from carbon chain. Minus psi effect groups. Who asked? Dhruva, you asked, no?
Shravan.
Shravan, got it?
Yes, sir.
Applications of inductive effect. Side heading. Just on 10-15 minutes, I'll give time, students. Just refer everything after finishing this. Just refer and ask doubts. Yes, whatever the topics we learned today, little high range. Applications of inductive effect. One is to explain stability of carbocation. Take this pain, students. Somewhat you may find difficult. I tried my level best to give it easier way only. Easy methods only I selected and I explained, and I explained slowly also. You just practice twice, thrice. It will be easy and it will be helpful. Carbocation means, see students, CH3, CH2 plus. Stop writing, all of you. Listen carefully. Please keep your videos on. CH plus. Like this they'll give. These are the carbocations. Carbon with positive charge. Positively charged species are called cations. Carbon with positive charge. Carbocation. Cation. See students, this positively charged. What is the meaning of positively charged carbon? there is electron deficiency. Electron deficiency. There is empty orbital in carbon. So here, out of 4 valency, this one hydrogen is there. One empty orbital is there. So it is getting positive charge. So if any group is ready to give electron, ready to fill this deficiency, then it will be stable. Otherwise, it won't be stable. It is like I am in problems financially. 2 members came to help me. Dhruva also is in the same problem. How much money I need, even same amount he needs. For me, 2 members are providing, they are helping me. For him, only 1 member is ready to help. Who will come out of the problems fast? Myself or Dhruva? Tell me, students.
If Jeff Bezos comes to help me, then obviously I will come out of the problem.
Sorry?
If Jeff Bezos comes to help me, then I will come out of the problem.
No. Both are getting equal amount.
Then NASA will come to help you, sir. Don't worry.
No, not like that. Here, the 2 members are ready to help me. No, those 2 members are how much they are helping. Suppose Tanmay is giving 20,000, Anaga is giving 20,000. I need 50,000 urgently. They are ready to give 20,000. Dhruva also need 50,000, but for him only Samarth is ready to help. That also he can provide only 20,000. Who will come out of the problems easily? Myself or Dhruva?
Yes, sir.
Who is more rich, sir?
You.
I am only, because I am getting more amount from 2 people. He is getting same only one from 1 person. No, he has to wait for some time. So after some time, I'll be more stable. He takes much time to get stable. Okay, same thing you apply here. Here carbon is in problems. Carbon is in problem. Positive charge means it is in problem. Deficiency of electron. When we keep positive charge, if there is any deficiency. Now methyl group. Once go to the previous. I know you no need to go to previous slide. Methyl group, in which case I gave plus I effect. Plus I group means it is giving electrons. It is giving electrons, ready to give electrons, electron donor. So methyl group is giving electrons. Here also positive charge is there. 2 groups are ready to give electrons. 3 groups are ready to give electrons. Which will be the more stable? Tell me, students. First one or third?
Third one.
Third one. Why?
Because more number of groups are ready to give
Very
electrons.
more number of this is called plus I effect group, isn't it? Here how many plus I effect groups are there? Only 1 plus I effect group is there. Here how many plus I effect groups are there? 2. Here number of plus I effect groups are 3. Understood? Now this is called primary carbocation. Why we call it is primary carbocation, students? Positively charged carbon is connecting with only 1 carbon. This is called second degree carbocation. Why we call it is second degree carbocation? Positively charged carbon is connecting with 2 carbon atoms. This one is tertiary carbocation. Tell me, students, which is more stable now? Out of primary,
Tertiary
tertiary. From this, what we can say, stability of carbocation is directly proportional to number of plus I groups. Yes or no?
Yes, sir.
Yes.
Directly proportional to number of plus I groups. This is very, very important. So from this we can decide stability of carbocation. Stability of carbocation. Shall I give one more application, students? This you
Yes,
understood
sir.
clearly?
Yes, sir.
Yes.
Okay. Next one. Second one is to explain acidic strength of carboxylic acid. To explain acidic strength of carboxylic acids. HCOOH. While explaining, please don't write, friends. Now you write. Now you can write. While explaining, don't write. See, students, which is more acidic means acids readily donate H plus ions, isn't it? Acids readily donate H plus ions. Which is more acidic means which is ready to donate H plus ion. Which is readily donate H plus ion. We'll see. So first we'll see if after donating H plus ion, what would be their condition. CH3COO minus. See, students, after donating H plus ion, their condition will be like this. This which is more stable. We have to see, this is called conjugate base. After donating H plus ion, whatever the negative charge we get, that is called conjugate base. This base is obtained from acid. So in that, which is more stable, that is readily donate H plus ion. So last time, even this time, Sonu Sood helped so many people during Corona time, isn't it? Lockdown time. He helped in different ways. He has so much money. No, that also we can't tell. Those who are having so much money, they all may not be good donors. Good heart should be there. He has both, so he could do it. Same help I can't do. Same help I can't do. Because all things or two things should be there. I said, no, first one, money should be there. Second thing, good heart should be there. I have good heart, but I don't have proper amount. That case, I cannot be the good donor, because after donating everything, I have, someone has to donate for me. I won't be the stable. If I have 10 lakhs, I may donate 10,000. After having 10 lakhs, donating 10,000, after losing 10,000, I may not lose my stability, isn't it? That also we have to check. Same thing, if I do, I won't be stable, so I am not a good donor. Okay, same thing here also. After donating also, the existence we have to see. After donating, whether the conjugate base is stable or not stable, we have to see. Here HCOO minus, it is having electron density here. Hydrogen is not electron donor, hydrogen is not electron withdrawing. It's simple, neutral it is. Now if you see here, negative charge is there, means it is feeling somewhat burden by keeping electron density over oxygen. After donating H plus ion, O is getting more negative charge, so it is finding somewhat burden. For that burden, again this group is giving extra burden. Here two groups are giving extra burden. Okay, here this one also I will compare with general example. I am carrying 10 kgs weight. I am finding difficult little to carry long distance. I am finding difficult. That one student came and asked, "Sir, can I help you?" In that case, some weight, some whatever I am carrying, some I can give to him so that I will feel somewhat comfortability. Instead of that, second case, I am carrying 10 kgs weight, student is carrying 2 kgs weight, he is finding difficult, he told, "Sir, can you carry this one also?" With the 10 kgs weight, I am finding difficult. Again, he is giving two more kgs. He is giving extra burden to me. First case, he is taking somewhat burden from me. Second case, he is giving more burden to me, extra burden to me. In which case, I am least stable. Tell me, students, first case or second case?
Second case.
Second case, I feel more burden, least stable. Same thing here also. Already it is carrying some burden. Here, this group, methyl group is plus I group. It is also giving electron. Finally, it transfer to here. Here, two such groups are giving electrons. So, where electron density will be more? First case or second case or third case? Where the conjugate base is least stable, you tell me, students?
Third case.
Third case, it is least stable because this is having electron density already. Again, these two plus I groups are there. This is plus I group, plus I group. Here only one plus I group. Here no plus I group only. So which is more stable, students? Stability is one more. If stability is more, it is ready to donate H plus ion. So acidic strength decrease. Formic acid is more acidic than acetic acid, propanoic acid. Acidic strength decreases. Why? Number of plus I effects increase from here to here. So from this, what we can say? Acidic strength is inversely proportional to number of plus I groups. If number of plus I groups increases, acidic strength decreases. Understood, students? After losing H plus ion, you have to check the stability. Which is more stable? Respective acid is more acidic. This much is enough. Only one example I will use to this extra with the upon carboxylic acids. Only with that I'll wind up this. Students, is it clear?
Yes, sir.
Next, one more example I'll give. You try to answer, students. Fluorine is there. It is connected to carboxylic acid. Chlorine is connected to carboxylic acid. Bromine is connected to carboxylic acid. Which is more acidic? I want to know. Anyone, can you tell, students? I'll write its conjugate base also. Fluorine is minus I effect group. Remember, fluorine is minus fluorine, chlorine, bromine are minus I effect groups. They take burden from this oxygen. In that, here all are minus I effect groups only. In this, which is more electronegative, you see. Which is more electronegative, that will take electrons more effectively.
Fluorine is more electronegative.
Fluorine is more electronegative, means minus I effect of fluorine is more. If it is more, see, students, it will take electron. This is finding difficult now here with negative charge. It is taking some burden more effectively than this one. Stability decreases. So acidic strength also decreases. Okay. Understood, students? Its conjugate base is more stable, so it is more acidic. Chlorine is reducing this negative charge faster than bromine. Chlorine faster than bromine. So here minus psi effect groups. Increases acidic strength. This 5 to 10 minutes I'll give time, students. You revise everything. Just overall. Wherever you get doubt, please ask me now only. Go through
Sir,
it.
sir, for that S and R configuration of two chiral carbon atoms, can you explain that again, sir?
Two chiral carbon atoms. Okay. I will take any one example and I'll explain. Is it okay?
Yes, sir.
This one example, right? Students, I told you, no, individually you try to write. Here, this carbon, if you select, this carbon is connecting with O, this carbon is connecting with carbon, hydrogen, here also carbon. Okay, here carbon, O, which will get first priority, O will get first priority. Next, here carbon is there, here carbon is there. So go for next groups. Here CHO I said no, C, double bond O means 2 times O you have to write H. Here groups are, this carbon is connecting with, first I am writing this carbon. Next, it's connecting with OH. So O I am writing next. Here, here, this carbon is connecting with O, carbon. So out of O and C, which will get first priority? OC. Next one is hydrogen. These groups are all not required. Maximum cases we can decide with this one. Dhruva, got it? This one?
Okay, yes, sir.
How to separate this? This carbon is connecting with O. I wrote here. Next carbon, I wrote here. Next one directly connected with the hydrogen. Next, if you want, you can write O here, H later. This, if you know, over. So this anyway first priority. Second priority, we are getting doubt this one or this one, this one or this one. So to decide, CC will get cancelled, O will get cancelled. Here,
O is priority.
O will get, O group will get first priority, isn't it? 2. This will be third, this will be fourth. So now priority. Dhruva.
Yeah, got it, sir.
Understood? Same thing you can do for second carbon also.
Yeah.
That individually how to write if you know enough.
Sir, you wrote COCH, right, for the first carbon.
Yeah.
Similarly, for second carbon, can you write and show, sir?
Here C double bond O, H is there, no? Chinmay? C O O H.
Yes, sir.
Which carbon you are asking, this one? No?
Sir, the third carbon is connected to the second carbon, right? How will express it while doing the finding?
Okay. I understood. This first one you got clarity, right?
Yes, sir.
So this I will erase. Otherwise, you will get confusion in between. First one, second one, third one. That let it be. Now, here O is there, C is there, H is there, carbon is there. This one also I erase. Okay, ma? O, this carbon is connecting with O, H, carbon. So anyway, O will get first priority. Now, this will get second priority, or this carbon will get second priority. We have to decide now. This carbon connecting with the O will write first, because it's descending order. You write descending atomic masses. H. These three hydrogens will keep last. O will keep first with this carbon. Next, if you go to this carbon is connecting with
OCH.
Yeah, O C H. You only told CC in fighting, both will die. O will die. Carbon and hydrogen, which will remain?
Carbon.
Then which will get first priority? First priority means next priority. This.
Yes.
3, 4. Very simple. Don't make it complicated. Over.
Yes, sir. Thank you, sir.
Dhruva, got it?
Yes, sir.
Any doubts, students? Other students? Only this question.
I don't have any doubt.
Okay, students. So shall I wind up the session now?
Thank you, sir.
You prepare all these things. Somewhat you may find difficult, student, but my side 100% I try to give clarity. Means in MSc only, MSc BSc we learned this one. You are learning in 10th standard. So now for IITs and all, because of that, in +1, +2 also they are teaching. So somewhat high level, no, means beyond your level. So still you tried, students. Number of times if you practice, it will become easy. Thank you, students. Bye bye.